beginning area of the drive. So if you have the MFT, you might be able to determine what the files were and where you can go get stuff. So if the MFT is in the green, you may actually be able to tell where your files are and skip some of the locations of where this bad head is. If you have a Mac, well, the table actually starts right in here, 409, 640, 42. So in this case, the actual table, which would have been the catalog, is destroyed. So I actually will need this head in order to get files back other than carving them. Otherwise, I'll have a problem. But you can know a lot from just looking at that type of information. So if I have to replace the head, I could actually go through the process of reading this. Then this is actually where I actually start physically, like disassembling, reassembling drives. I use a foil head tool. Now, some people know these things to be like head combs. There's a tool that's called a head comb. You can slide in between heads and you can remove them. I use something similar to a Sudafed container, and I can make them out of this for like 50 cents. And you know, it's really rough too when you go to the store and you go, look, I need 50 boxes of Sudafed. When you're teaching class and you want to, you know, oh, I got 7 FBI agents in my class and I need anyway, maybe somebody can make a phone call and get you some Sudafed. Anyway. So ultimately, that's where we're dealing with, okay, I've been able to read the other 75%. Now if I replace this, I might be able to read this 25% and put that back into that location. Now those are a little bit more advanced methods, but it is possible to be able to tell that I have a bad head, still read data, and return something, and then fix it myself. Now there is one other problem that's very simple for you to fix, which is, anybody heard Star Trek sounds on their drive? Anybody hear phasers? You probably heard it, but you don't know you heard it. Okay. Here's what it sounds like. Nobody's heard that? Yeah? So normally what this would mean is that I've got a head stuck to the platter, or I got a spindle that doesn't turn, so the head's cannot read anything, so they'll make noises like this. So here's another one that you might have heard that's very similar. Anybody heard that? Yeah. So normally that means I've got a spindle that's not turning, my head is stuck. And in some instances, like for instance, there's some laptop drives that are like 80 gigs, that the head is stuck to the platter. All you literally have to do is open the drive itself and turn it with a screwdriver without touching the platters or scratching the platters. Turn the platter till it breaks the torque. It's called stiction, basically. We used to have this problem back in the early days when RLLs, MFMs, and stuff like that would actually stick. And what was the fix for it? Anybody remember the fix for stiction? Yeah, screwdriver, right? It was, right. And Secretary, my machine doesn't start up. Start it now. All right, awesome. Or you take it out and you spin it on the table in the opposite direction. That would do it too. But in this case now, they're actually really stuck. Now, the exception to this is that some of the newer Seagate and Western Digital hard drives that are now like in little mini towers and they're standing up on their end and you know, you jiggle the table and they go poof, right? Now what happens actually is that the platters are so heavy, in a lot of cases the spindle will break free. And the spindle inside the drive will not turn anymore at all. So if you open up the drive and you're not able to turn it at all, and the platters don't spin at all, then your motor is seized, and that's a more advanced replacement at that point in time. But if it does turn at all, and you can break the head free, you will probably be able to read your data and do okay. So there's one other really simple problem. Anybody plugged in, like you get a Seagate 640 and you plug it in, and all of a sudden, you know, it just doesn't power up at all. You hear nothing, no spindle, no nothing, no head movement. It just sounds completely dead. You guys had this one? So there's a lot of these that are actually just like this, like no power at all. You don't hear it spin up, and you're just like, it's dead. I don't know what's up. Well, they have a voltage suppressor on them. Anybody remember the keyboard fuses? Remember back in the early days in the ATAs and XTs? Yeah, some of them are older. All right, so, and how'd you fix the keyboard fuse? Yeah, you jumper it by stick a penny in it or something like that, right? So the keyboards had a fuse that if they blew, rather than blow something on the motherboard, you actually would have to resolder it on the motherboard itself to prevent the motherboard from dying. Well, on hard drives these days, you'll find these on the bottom of almost all of your 3.5-inch hard drives. There will be these two fuses. Now, basically, these suppressors, there's one, the smaller one, it's 5 volt, and the bigger one is 12 volt. So if you got 5 volt and 12 volt, now, I'm not just saying, let's go rip these off, okay? You know, you might, if you have no other alternative or you can't find a meter and test them, there is an option. It really won't do much damage. Almost all of these are near the power supply. So here's the power. Does it really get anybody that the power is like a lot wider than the serial port itself. I mean, like, what the? So the power itself, it will be by the power, it will be near the power, and you will see one of these two types of configurations that maybe will be sitting around somewhere with a smaller and a bigger one. And literally, you snap those suckers off, and the drive will spin right up. Now, most of the time, it's because you had a crappy-ass power supply. You got that? Your crappy-ass $50 power supply that you didn't want to spend $169 from some really nice, Coolmax or whatever, blew this thing, okay? You can tell a power supply by weight. If you can pick it up and it's like, ugh, then you had a good one. If you can pick it up and it's like, ooh, this is light, it'll be easy for me to carry. That is not good. Spend the extra $50 or whatever. Here's another thing. If you rip these off, don't plug it back into that power supply. That's probably the end of your drive. You will actually cause it like, oh, it didn't spin up again. No shit. Really, you just fried the damn thing now. So that's what's going to happen to it. You're going to blow the preamp on the head assembly or something. It's going to blow. So plug this into something else, okay? Get something a little bit better that you're working on your workbench or something like that to at least try to at least make sure that you can read this. But that's bad news. So on your electronic stuff, how do they basically burn? I'm going to go a little faster here for a second. This is what happens when you plug one in backwards. See down here in the corner? Smoke, fire, blah, blah, blah. That happens all the time on MaxStore drives. That's a very convenient thing that the chip will burn. And this is the motor control chip. This chip basically will cause the motor to spin. And without that chip, it won't work. So you could just swap this board, but if you needed to, you can unsolder this. Sometimes it's not that obvious. Most of the time, you can tell by... Okay, they cut me off. They said, you're done. And, oh, well, I'm the last guy, right? Do I get like one more minute to finish up?
Oh, no, actually there's a question, or two questions from the guys in the streams. First question is there a link, or do you have a web page or a single source where everybody can get all of the tools that you referenced in your slide about 4 minutes in?
Yeah, if you go to myharddrivedie.com, so the question is whether or not, and I don't have a mic anymore, so if you go to myharddrivedie.com, I have all the information for everything on there. So there'll be a presentation page which will have all this and all the information for the slides, and I have text in the slides in the bottom and stuff that they'll be able to read or something, but that's about it from that standpoint. But I do have other content on the page, that videos and movies. Yes, sir. Next question?
And the second question from the streams was, how much of this technique basically applies to solid-state drives?
Not very much of it. The only part that really applies to solid state is similar to this resistor problem that we actually have, where we have like a transient voltage suppressor. USB memory sticks and a lot of the solid state drives will have a similar resistor pack on their disk. The problem is that when they blow, they're a lot smaller and harder to find, so you really have to use a meter to test them. But in some cases, the exact same thing applies, where you can rip them off and then the drive will work correctly. But as far as the rest of the content applies, other than I'm going to solder or something, nothing much. It's a much more complicated recovery for solid state stuff, and that will be coming up in one of my other future. I have a previous solid state presentation. It has become more advanced than that, and I will eventually have another one that will tell you how to really do it, but there's only 3 people in the whole world that can. Okay, anyway. Yes, sir? Yes. So the question is basically about the secure erase, and there's 2 versions. There's an enhanced secure erase and a standard secure erase. And your question with regards to their existence is? The second one, supposedly would wipe with random data. Yes. No, the enhanced one actually does use randomized data, and it actually does do. So you may have actually still run the first version or something. When you're running the enhanced, you should get 2 choices. Like if your drive supports it, you'll get the standard one and the enhanced one as 2 choices on the menu. And the enhanced one does, and I have tested it, does randomize data and does put a pattern of random data in different orders on the drive. But I'm not sure what your problem was with that, but there are some issues with regards to motherboards. Like Intel motherboards freeze the command so that the command can't run correctly, and so you have to do like this cold boot trick in order to get around them. Send me a more specific email or something, but they do work, and I do have a previous talk about those I did ShmooCon last year, top 10 things about hard drives, and I did it on that. Yeah. Yes, sir. Next. Right in front. There are some like TPMs and some black armors and stuff that can do that, and so you're right that if the key is like erased or wiped, but not the standard traditional drives that are still sold on their shelves. They still actually have to go through the whole process, but they're fairly quick at it. But they don't just erase the key. But some of the newer encrypted ones have some other alternate methods. I can still read the content from them, but I can't decode it. Yes, sir? Because the size was wrong? It says that this... Right. Yes. Okay. So there is a way to copy the serial number. What he's asking is he cloned a drive, but he had maybe some software that was dependent upon a serial number on the drive, and that something happened with the software not recognizing or something not recognizing the serial number correctly, or even things like Windows. Sorry? So yes, there is a way to do it. However, it does require a tool that can talk to the system area. So most of the tools are fairly expensive. There is some low-end tools that I have seen called pokers. So if you do a search for a poker, there are hard drive pokers. I am not condoning, piracy in any way, but I am saying that there is a way to actually duplicate a serial number and a model. You can even make like a model number change. You can make a 40 gig look like an 80 gig or whatever, but you can change those, and I've done so before. But you can duplicate that. You can even back it up. Yeah. Anybody else? Yes, sir. That's a lie. Well, okay, so he asked about life expectancy of a drive, maybe high-end versus low-end versus whatever. Bye, Scuzzy. Everybody else's drives are all cheap and crap, and even the Enterprise editions are, in my world, still not good. They have a lot to do with the components, how long components are baked, and those kind of things. But the mean time between failures is a complete arbitrary lie. If you do a search for it, you'll actually see that they actually even declare it as a lie, that they've never run a drive that long or even attempted to run a drive. They take some mean sector failure based on some older stuff. Now, in 2006, they changed drive manufacturing processes, and so the newer drives fail at a dramatic rate. The newer stuff, to me, is failing like, you buy 3 Western Digital drives, they may all be dead within 3 weeks of each other. Same thing of, Seagates and stuff like that. Hitachi right now seems to be the leader for me right now. It changes like every 6 months, though. But Western Digital has a real firmware problem right now that they don't seem to be openly declaring is a problem. Don't sue me. But it's there, and we know about it, and so things like that. No, I would say that new drives fail. You have no predictive rate for failure. It will fail in a week, 3 months, a day. It could be any number of things with regards to even problems with the firmware stuff currently on the new ones since 2006. Prior to 2006, I might have given them 3 to 5 years. Prior to 1999 and 2001, I would have given them 5 to 10 years, but not now. The new stuff, I don't trust at all, period. RAID 6, RAID, Mirror, anything else but that. Or Seagate, or SCSI. Yeah.
Since stuff changes so often, can you tell us briefly what the current situation is with the Seagate drives that have gotten a bad rep?
Okay, so they have, Seagate has a fix. He's talking about the firmware problems for Seagate. Seagate has a fix for their current existing problems. So for instance, if a Seagate drive is still operable, it can be updated, and the firmware can be updated just by getting their utility and updating it, and it will work fine from then on. If the drive fails, then we actually have some tables and a short that actually has to happen on the board in order to actually repair that. And it doesn't quite do exactly what you would expect. It's not like a perfect fix or repair. And then there is some third firmware problem. So we can read the data in those other 2 instances, but there's this new introduction of a third firmware problem that nobody has correctly, completely reverse engineered, or we don't have a large enough subset of the drives, but they do still fail, and we can't recover from them. And so far, even the drives that I have forwarded on to Seagate and their own data recovery company, what a, anyway, conflict of interest was what I was going to say.